is the frequency of the airwaves. So how many peaks do we have per unit time? And this determines what is called the pitch. So basically, if you hear a high frequency sound versus a low frequency sound, this depends on the number of waves that are traveling through the air per unit time. So on this, for example, we're looking at 250 milliseconds up at the top and the bottom. On the bottom, we see there are many more waves occurring in that time period. So this would be a higher frequency sound compared to a lower frequency sound up here. The other characteristic that we're interested in is the amplitude of the waves, which is measured in decibels. So when we talk about sounds that we can hear, we talk about a specific range of decimals that our ears can pick up. And that's just the amplitude here on the So just to review some of the information about the ear, so this is just a review of anatomy. So we have the external ear, the middle ear, and the inner ear. So we have these pressure waves that are going to be traveling through the ear canal, or the external acoustic meatus, hitting the tympanic membrane and causing the ossicles to vibrate. So if we have a blow up of that, so we have our tympanic membrane here, we have the three ossicles that transmit that sound to ultimately transmit it to the inner ear. So we have the three ossicles, the malleus, the incus, and the stapes. And when we look at the middle ear, we have two membranes that separate the middle ear from the inner ear. So one of these membranes is called the oval window, which sits right underneath the stapes. And then the second membrane is the round window that sits immediately underneath the oval window. So those two kind of work in conjunction. When we have the stapes hitting on the oval window, that's going to make the round window move out. So as the oval window moves in, the round window moves out, so they're moving in opposition. That round window helps to dissipate pressure in the fluid in the chambers of the inner ear. So in the inner ear, we're talking about hearing, so we want to focus on the cochlea, which is a coiled snail-like structure here. And so what we're looking at here is just the cochlea unrolled, and we're looking at a kind of a longitudinal section. So we're looking inside the cochlea. So if you remember from anatomy, the cochlea has the bony labyrinth surrounding the membranous labyrinth. That membranous labyrinth is just basically sort of a fluid-filled sac that is completely enclosed, separate from the bony labyrinth. And the two regions or chambers of the bony labyrinth, so the top one here is the scala vestibuli, also known as the vestibular duct. The lower one is the scala tympani, or the tympanic duct. So along most of the cochlea, those are separated by the membranous labyrinth here, which is called the cochlea duct or the scala media. And this is true again for most of the cochlea, but down at the very distal end, the scala vestibuli and scala tympani are connected at this region called the heliotrium. So these chambers are filled with fluid, and we have two different fluids, one that fills the bony labyrinth and then one that fills the membranous labyrinth. So in the vestibular and